welcome to lesson 3.2, solving quadratic equations by factoring. Previously we were working with expressions and factoring, and now we're extending to factoring and solving the equation. An equation of the form ax squared plus bx plus c equals 0 contains a quadratic or a second degree term. That is a term with a variable that is squared and no term of higher degree. Such an equation is called a quadratic equation, where a, b, and c are constants and a cannot equal 0. Example 1. Solve each equation, then verify the solution. Part A, we have x squared plus 12x plus 32 equals 0. So first, we need to factor. Using our AC method, we have 32. So we need to find two numbers that multiply to 32 and add to 12. 32 has factors of 32 and 1, 2 and 16, and 4 and 8. I'd say 4 and 8 add up to 12, so let's use those. And we'll have x squared plus 4x plus 8x plus 32 equals 0. Now we need to split our equation, and we can factor out an x here, leaving x plus 4, and an 8 here, leaving x plus 4, all equal to 0. Hence our factors here are x plus 4 and x plus 8. Now since this is an equation set equal to 0, we can say that x plus 4 equals 0, solving giving us an x equals negative 4. Here as well, x plus 8 equals 0, leaving us with x equals negative 8. Now those may be our solutions to our equation here, but first we need to verify the solution. So let's go ahead and check and sub back into our original equation. X equals negative 4. We have negative 4 squared plus 12 times negative 4 plus 32 equals 0. 16 minus 48 plus 32 equals 0, and 0 does equal 0. So that means that x equals 4 is a verified solution. Now x equals negative 8. We have negative 8 squared plus 12 times negative 8 plus 32 equals 0. 64 minus 96 plus 32 equals 0. And 0 does equal 0. So x equals negative 8 is also a verified solution. Let's work through another one. Part B. 3x plus 1 all multiplied by x minus 6 equals 22. Well, we don't even have what looks like a quadratic equation yet, so first we should distribute and see what we get. We have 3x multiplied by x minus 6 plus 1 all multiplied by x minus 6 equals 22. Distributing, we get 3x squared minus 18x plus x minus 6 equals 22. Collecting like terms, 3x squared minus 17x minus 6 equals 22. But we need our equation set equal to 0, so let's move that 22 to the left-hand side, and we get 3x squared minus 17x minus 28 equals 0. Now we have a quadratic equation, so we can go ahead and factor using our AC method here. We have 3 times negative 28 here, which gives us a value of negative 84. So now we need two numbers that multiply to negative 4 and subtract to 17. Factors of negative 84 are negative 84 and 1, 84 and negative 1, 21 and negative 4, or negative 21 and 4. I'd say negative 21 and 4 here are our factors, so let's plug those in. Now we have 3x squared minus 21x plus 4x minus 28 equals 0. Splitting our equation down the middle, we can factor out 3x here, leaving us with x minus 7, and a 4 here, leaving us with x minus 7 equals 0. So our factors will be 3x plus 4 and x minus 7 equaling 0. Separating those, we get 3x plus 4 equals 0, 3x equals negative 4, and x equals negative 4/3. And x minus 7 equals 0, giving us that x equals 7. But we need to verify our solution, so let's go ahead and check first. And we have x equals 7, which gives us 3 times 7 plus 1 onto 7 minus 6 equals 22. 21 plus 1 times 1 equals 22. It is 22 times 1 equals 22, which 22 equals 22. So x equals 7 is a good solution. Let's check x equals negative 4/3. We got 3 times negative 4/3 plus 1 multiplied by negative 4/3 minus 6 equals 22. The 3's cancel here, leaving us with minus 4 plus 1 multiplied by minus 22 over 3 here, which equals 22. We have minus 3 times minus 22 divided by 3 equals 22. Our minus 3's cancel, giving us with 22 equals 22. And hence, x equals negative 4/3 is also a good solution. Alright, moving along. If the product of two numbers is 0, then either number or both numbers equals 0. That is, if AB equals 0, then A equals 0, or B equals 0, or A equals B equals 0. This is called the zero product property. Example 2. Solve each equation, then verify the solution. Part A. 3y squared plus 75 equals negative 30y. Well, let's set this equation equal to 0 first. So we have 3y squared plus 30y plus 75 equals 0. Now we have a quadratic equation. I immediately notice that we can factor out a 3 here, leaving us with y squared plus 10y plus 25 equals 0. Our constant here cannot equal 0, so we need to continue and go ahead and factor. So our AC here is 25, and what two numbers multiply to 25 and add to 10? Right away I know that is 5 and 5. So I'm going to go ahead and skip a few steps and move to the fact that 5 is our factor here, so it is y plus 5 and y plus 5 equaling to 0. And hence y plus 5 equals 0. Solving for y, we get negative 5. We need to verify a solution, so let's check and plug back into the original equation, and we have 3 times minus 5 squared plus 75 equals minus 30 times minus 5. 3 times 25 plus 75 equals 150. And 75 plus 75 equals 150, and 150 equals 150. Hence, y equals negative 5 is our one and only solution. Part B. 5x squared equals negative 20x. Let's set our equation equal to 0. 5x squared plus 20x equals 0. Well, right away I can factor out a 5x, leaving us with x plus 4 here equaling to 0. So from our zero product property, I have 5x equals 0 and x plus 4 equals 0. And a constant cannot equal 0, so x has to equal 0 in this case, and then x equals negative 4 in this case. So let's check to verify our solution. We'll use x equals 0. Plugging in, we get 5 times 0 squared equals negative 20 times 0. and 0 does equal 0. So that is a verified solution of x equaling 0. Now x equals negative 4. We get 5 times negative 4 squared equals negative 20 times negative 4. 5 times 16 equals 80, and 80 does equal 80. Hence, x equals negative 4 is also a solution to this equation. Example 3. Solve this equation, then verify the solution. Square root 6 minus x plus 4 equals x. So we need to solve for x. But since we have a square root here, we need to inverse that by squaring. So let's isolate our radical first off. Square root 6 minus x equals x minus 4. Now let's go ahead and square both sides. And we're going to have 6 minus x equals x minus 4 all squared. We need to collect like terms, so we're going to have to distribute our x minus 4 squared, giving us 6 minus x equals x squared minus 4x minus 4x plus 16. Collecting like terms, we're going to have 6 minus x equals x squared minus 8x plus 16. But we need to set our equation equal to 0, and since our leading coefficient of x squared is positive on the right-hand side, we'll have 0 on the left-hand side here. We're going to have 0 equals x squared minus 7x plus 10. So now we need to go ahead and factor this quadratic equation, and we're going to get an AC of 10. And what two numbers multiply to 10 and add to 7? In this case, negative 2 and negative 5 are our choices. So we have 0 equals x minus 2 and x minus 5. Setting that equal to 0, we will get x equals 2, x equals 5 for our solutions. But we need to verify our solution, so let's check. X equals 2. Square root of 6 minus 2 plus 4 equals 2. Square root of 4 plus 4 equals 2. 2 plus 4 equals 2. And 6 does not equal 2. So in this case, no, x equals 2 is not a solution. But x equals 5. Let's look. Square root of 6 minus 5 plus 4 equals 5. Square root of 1 plus 4 equals 5. 1 plus 4 equals 5. And 5 does equal 5. So our only solution here is x equals 5. Let's do one more example. Example 4. The sum of a number and the square of a number is 20. Determine the number. So when it says sum here, we know that we're having an addition. Let x be the number. So it says that the sum of a number and the square of the number is 20. Square of the number looks like that, whereas this is the sum, and that all equals 20 here. And set the equation equal to 0 with our leading coefficient of x squared. We'll have x squared plus x minus 20 equals 0 here. Now we need to go ahead and factor, and we have an AC of 20. So what two numbers multiply to 20 and subtract to 1 in this case? I believe the factors here are positive 5 and negative 4. So we're going to have x plus 5 and an x minus 4 as our factors. Setting equal to 0, we get an x equals negative 5 and an x equals positive 4. Now we need to check our solution, and we get equals negative 5. We have negative 5 plus negative 5 all squared equals 20. Negative 5 plus 25 equals 20, and 20 does equal 20. So x equaling negative 5 is a good solution. How about x equals 4? 4 plus 4 squared equals 20. 4 plus 16 equals 20. And 20 equals 20 again. Hence, x equals 4 is also a good solution.